Hello, we are team number 1. My partner Sofia and I, Chris, we're going to present our statistical project about the water quality in Mexico. The content that we're going to be talking about during the presentation, first we're going to talk about the aim of the study, then about the contribution of the study, after that, the description of the data and variables, also the type of variables, and then the relationship among variables. After that, we're going to see the data gathering process and then the problem definition that this data is going to address. After that, we'll see the main decision for this data, meaning the scientific hypothesis and the statistical hypothesis. There were built 3 scientific and 5 statistical hypotheses, and finally some conclusions. Contaminated water is one of the most environmental stress concerns in the world. The supply of safe and clean drinking water is a challenge that needs to be addressed. The environmental contamination of natural resources is escalating as a result of industrial activities and technological developments. The contamination levels of freshwater ecosystems are increasing due to the discharge of untreated or improperly treated wastewaters. Affordable, clean water has always been an issue of interest to the Mexican public, especially because some states have problems with the water quality and the effects that this drinking water has on the citizens. In 2019, CONAGUA established 2,764 water quality monitoring sites throughout the country. The main purpose of this study was to make a proper analysis of the status of the water quality in each state of Mexico, in order to determine the states with the lowest and highest quality of water. The contribution of the study will allow the government to take action to provide and improve the quality of the states with the lowest status according to the previously parameters established and following standard water quality guidelines, in order to provide an equal quality of life for all their citizens and living beings.
For the description of the data, we are focusing on the analysis of the surface water quality, and we considered 8 variables which are used to measure the degree of contamination of the water monitored in the majority of the sites. CONAGUA has a criteria for the monitoring sites that indicates the quality of the water following a superficial scale with different parameters regarding each variable separately. The superficial scale chooses excellent, satisfactory, acceptable, contaminated, or strongly contaminated. The 8 variables monitored are biochemical oxygen demand at 5 days, which indicates the overall concentration of organic substances by their effect on the respiration of a microbial biomass. Since 1908, this analysis is measured at 20 degrees Celsius over 5 days in the dark. Then we have the chemical oxygen demand. This indicates the amount of substances that are dissolved or in suspension in a liquid sample that can be oxidized by a chemical medium. Then we have the total suspended solids, which are particles larger than 2 microns found in the water column, solids drifting or floating in the water from sediment, silt, sand to plankton and algae, organic particles from decomposing materials, and even chemical precipitates. This is a significant factor in water clarity. Then we have fecal coliforms. Fecal coliforms is one type of coliform bacteria that is found mainly in animal digestive tracts and feces, and fecal coliforms are a more specific indicator of fecal contamination of water. Then we have Escherichia coli, more commonly known as E. coli. This is a species of fecal coliform bacteria. E. coli almost always comes from animal feces, and E. coli is considered to be the best indicator of fecal water contamination. So if E. coli is present, harmful bacteria or other pathogens may also be present. Then we have Enterococci or Enterococcus bacteria, which is a type of fecal bacteria found in animal feces, and it is also considered less likely to appear in water except in nutrient-rich environments. This bacteria is commonly used to assess human health risk associated with recreation in fresh water. Finally, we have a percentage of oxygen saturation, which is the amount of oxygen dissolved in water into a certain temperature. And finally, toxicity, which is a direct harmful effect of a substance on organisms. All of these variables are continuous variables. Then we have the degree of interaction between the variables. The first interaction will be the coliforms, which are fecal coliforms and E. coli, and the Enterococci, which are highly correlated between themselves, and they all form a total number of coliforms present in water. Then we have the coliforms that should appear in the biochemical oxygen demand at 5 days analysis, which indicates the overall concentration of organic substances present in water. And finally, we have the percentage of oxygen saturation that can affect the presence of bacteria. Because even though these are facultative anaerobic bacteria, meaning they don't require oxygen, they grow better in the presence of oxygen.
Now we're going to talk a little bit about the data gathering process. CONAGUA carries out throughout the National Network for Water Quality Measurement the monitoring of the main water bodies of the country. Permanent monitoring of the water quality throughout 5 years was established in 2014. The definition of several categories of bodies of water facilitate the management of each one of them. The categories are based on the characterization of the water. The National Network for Water Quality Measurement of Mexico, R&M, for the acronym in Spanish, is made by LOTIC water bodies of water that move always in the same direction like rivers, springs, and streams. LENTIC, still or stagnant inland waters like lakes, lagoons, ponds, wetlands, and swamps. And coastal and underground. In total, there are 4 types of bodies of water. Even though there are different methods, the monitoring of variables only includes physicochemical and microbiological parameters, in accordance with the type of body of water. The focus of this study are the surface waters that include all the bodies of water with the exception of underground bodies of water. The information is consolidated in one file and classified by type of body of water and by taste. The R&M's strategy is a global system through monitoring components with defined objective and the evaluation of the water quality through the analysis of several physical, chemical, and biological in the various aquatic systems. Because the R&M determines the quality of water with frequencies and suitable parameters in the main bodies of water, this allows the evaluation of the effects of climate change, the management of national and international sites of interest such as the zones with the lowest quality of water, protected touristic zones and natural areas, and the improvement of the sources of supply of diverse population and the habitat of the flora and fauna. The problem definition that this data is going to address are the following. First, conduct assessments of water quality trends at the local and regional levels to confirm the state with the supposed worst water quality and best water quality in Mexico. Second, evaluate the performance and compliance of the regulation of pollutant control in water. Third, identify problems associated with the specific contaminants in the aquatic environment. 4. Propose a water treatment designed to improve the water quality of a specific state. And finally, meet the water quality standards of international agreements and commitments.
For the scientific hypothesis and our statistical hypothesis, we first have the first state, which is Nuevo León. So if the superficial water of Nuevo León has a low content of suspended solids and natural conditions and a low content of organic biodegradable matter, then the water quality of its superficial water should be considered a good water quality. The first statistical hypothesis that we have for this one would be the median of a biochemical oxygen demand during 5 days from the superficial water network of Nuevo León is less than or equal to 6 milligrams per liter. The null hypothesis would be median less than equal to 6, and the first hypothesis would be greater than 6, median greater than 6. Then we have the median of total suspended solids from superficial network of Nuevo León is less than or equal to 75 milligrams per liter. The null hypothesis would be median less than equal to 75, and the first hypothesis would be median greater than 75. Then we have Tabasco. If the superficial water of Tabasco has a bacteriological contamination and a residual water discharge, then the water quality of its superficial water should be considered a low quality. The first statistical hypothesis would be the median of Escherichia coli, E. coli, from the superficial water network of Tabasco is higher than 150 most probable number of E. coli per 100 milliliters. So the null hypothesis would be median greater than 800, and the first hypothesis would be median less than equal to 800. Then we have the median of chemical oxygen demand from the superficial network of Tabasco is higher than 40 milligrams per liter. The null hypothesis, would be median greater than 40, and the first hypothesis would be median less than equal to 40. Then we have Jalisco. The superficial water of Jalisco should be considered a satisfactory quality for aquatic life and recreational use with primary contact and other uses when there are small traces of bacteriological alteration of the quality. So the statistical hypothesis in this one would be the median of fecal coliforms from the superficial water network of Jalisco is less than or equal to 200 in the most probable number of fecal coliforms per 100 milliliters. The null hypothesis would be median less than equal to 200, and the first hypothesis would be median greater than 200. So, in conclusion, statistics is a process that leads us to discovery in science. It allows us to make decisions based on data and learn from it. In this study, the statistical answers that we obtain from the data analyzed can lead to a big improvement in the water quality in Mexico, and therefore lead to a better quality of life for Mexicans. It is important to understand how the bodies of water in Mexico are managed and how new clean water technologies can be introduced in order to help move in the direction of the Sustainable Development Goals by the United Nations, in order to change the world for the better. Water quality issues due to anthropogenic and natural contaminants affect the amount of water available for use. The percentage of society lacking suitable drinking water is increasing by the day. That is why it is necessary to innovate through research to develop efficient, economical, and technological methods to produce clean water. We seek to propose an efficient, cheap, and high-impact analysis to achieve quality drinking water. Improving water quality by removing contaminants can boost economic growth in countries and greatly contribute to poverty reduction. Thank you very much for your attention. This was all for today.